Okay, great. So, uh, um, so how is it going so far? Is it going okay? Is it going fast or slow? And what was the last topic? Probably this is where Swati left off, right? This demo was done. Yeah. All right. All right. So, do you have any questions before we start? So Achintya and Srinivas, we will be and the Anand, I will be taking the today's session as Swati is out of station. All right. So should we start then? All right. Great. So we were done with the partitions in the previous session, and all right. So the usual DDL operation, DDL stands for uh, data definition language, whereby you can modify a table, create a table, and where you're changing the definition of your data. Okay. So those kind of operations are also possible using Hive. So far, probably we must have discussed how to import data into tables, how to export data, how to partition, how do the partition table work. So we must have discussed all of that. So do you have any questions till now? So, all right. So you understand the value proposition of Hive and Pig, of Hive as well as Pig. All right. You also understand there are two kinds of tables, managed and external. All right. Loading data we have understood, and great. All right. So if you have to, change the particular column, you can do that, or you can rename a table itself exactly the way we do in SQL. And the syntax is like more like Oracle, where we say alter table, table name, rename to new table. Okay. And then if you have to change the column from one name to another, we can do that. Also, we can change the data type of a column. Okay. And when you are changing the data type of the column, I mean, that is only possible if the data type is compatible. The new data type is compatible. Okay. Similarly, you can add more columns, and you can drop a partition or add more partition to this. All right. So far we have discussed the managed tables. Okay. You can also create external table. The only difference would be addition of external keyword here. And again, when do you create an external table? Whenever you do not own the data. If you do not own the data, that time you create an external table. Otherwise, you create an internal table. Because if you drop an internal table, the or internal or managed table, it's the same thing. So if you drop an internal table, the actual data will get deleted. Okay, the underlying data will get deleted. While in case of external tables, the data would not get deleted. All right. So we define the structure of table, saying these are our columns, and then we also define the the separator of the fields in the input file, and then we define the location of the data. Okay, and then we can start selecting the records and start working with this. All right. A better thing to do would be to try it out. Okay, so let me log in into. Is the font visible now? All right. Or should I increase? Okay. Achintya, Akshay, Dayanand, Serena, Sarad. Okay, great. So is the font visible to all of you? So I logged in into the cluster and ran Hive. So, all right. So there, let me just create a database and I call it. All right. Use 20 June and let's create the table. So also in the meantime, let me just open Hue. So are all of you comfortable with our Cloud Labs? Is there a doubt? Are you able to use it? All right. So only Achintya is able to use it. All right. So the data we are talking about in this example does not yet exist. Okay. So, all right. So Achintya is using, Akshay is using, sorry, Sarad is using, Srinivas is already using Cloud Labs. Okay. Great, great. So Dayanand is also using it. All right. So we'll just try to create the table first, and then what happened to our data? All right. So I'll just create a table with this folder as this file as the location. This is not a great idea. Let me. I'm logging in again. All right. So I think these files got deleted or something. Let me copy these files. Hadoop fs copy from local and into slash data, and yeah. So I'm copying these files which are supposed to be there for the assignment in the slash data. Okay. Now all of you that keep in mind, Sarad's question is, post completion of this course, will the access to Cloud Labs be active for me? So after this course completes, you may not be able to uh, access it after you have finished your project. Okay. And the project submission is generally 1 week after the last class. All right. But in case your project is getting delayed, or any of this is getting you want it for a few more days, just let us know. Okay. So that we can plan our capacity of Cloud Labs accordingly. All right. Now we have moved it to slash data. Okay. So we have this data lying here. And so what we are trying to do now is create these tables. All right, let me just create this. All right, it says that return code file already exists and path is not a directory. All right, so please note the errors which we are getting here. It says that the parent path is not a directory and there is already a file existing there. Okay. Now we can just rename this any of this. All right. Why are we getting this error? Because this location has to be a folder. Okay. This location has to be a folder, and therefore when it is trying to create this folder, here, either it could have found the folder with the same name, then it could have been okay. Otherwise, since uh, since there is a file name existing with the same name, it won't be able to create a folder with the same name. All right. In in OS, you cannot create a file and the folder of the same name under a same parent folder. Okay. So let me just rename it. Let's say we call it, and all right. Now it won't have any problem. Okay. So now you can see my stocks. It says there are zero record. All right. Now what would happen if I copy this particular file into the folder, into this particular folder? So you can see that the moment I created this table, it has created the corresponding folder. So if I copy that file, copy this data file, this particular file into that folder, what would happen? So let's say I select this file and copy it to slash data. Okay, sorry. Okay, I say okay. Let's see. Oh, it's not copied. I would. All right. So here you have this folder containing our data. Now, if you do go back and do select star from my stocks, you can see the records. Okay. The other way, of course, would have been that we did a load on a particular file. Okay. So I'm just making you comfortable with the fact that the Hive basically reads the Hive will read the file, apply, I mean, and then represent the data in this format to you with these columns. And so is everyone clear what I tried to do? So we basically created an external table, specified our location as this one, and it failed to create in when we tried first. Reason was that there was a file with the same name as this one already existing. Okay, so but it has to be a folder. Had it been a folder already, then it wouldn't give an error. Okay. Now once you have done it, and the other way, we so when we created a table, it created a folder, underlying folder, and then either we can directly copy the data into this folder, or we can say uh, load and load the data into that table. Okay. We could also say, just like manage tables, load into, I mean, if you had seen this, something of this sort, load data local in path, kind of this one, till here. All right. Yes, table name is case sensitive. All right. So that's common thing with whether external table or internal table. You, whenever you are creating a table, there is a folder in HDFS in which the data is lying, and either you can do load into that table and load the data, or you can load the you can just copy the data. Similarly, if there is a folder already existing at the same location at which you are trying to create a table in the HDFS, the same data will be used. Okay, so till here, both tables are same, internal or external. Okay, but the moment you try to delete a table, okay, if it is managed table, it will drop the data. If it is an external table, it will not drop the data. So Sarad's question is, so if I put any file in the folder, okay, Hive will load the file, or it should be aligned with the structure of the table. It should be aligned with the structure of the table. It should have these fields separated by a tab. Okay. Otherwise, it will give you an error at the runtime. Okay. The way we tried to copy just now this particular file, if we had tried to copy some other file having some other format, it would give an error. All right. Vijay's question is, so loading via table or copying file into the folder results the same thing. Loading via table, yes, it results the same thing. All right. So, I mean, the idea is to make you comfortable with the way Hive is trying to handle the data, or how Hive is working. So the moment you create the table, first it will try to find out whether there is a folder at the location where we are trying to create a table or not. If it is there, then it will use that folder. Otherwise, it will create a fresh one. And if it fails to create a folder, then it will give you an error. All right. Now, once the table is created, either you can directly copy the data into the folder of the into the folder of Hive table, or you could use something like load. If you are using, if you are loading a file from a local file system, okay, if you say load local, then it will copy the data into that folder. Or if you are saying uh, load and the file is in HDFS, it will move the file. Okay, it will move the file. Now, if you delete a particular table, the underlying data will get deleted. I'll show you this. The underlying data will get deleted. Uh, in case the table is managed table, the underlying data gets deleted. In case the table is external, the underlying data does not get deleted. So there's a basic difference between external and internal. In case of external, if you drop a table, the data doesn't get deleted, because when we say external, we are saying that the data is external to us. Okay, so don't touch the data when we are dropping the table. Okay, so let's say, what was the table name? My stocks. Let's try to delete the table. Can anybody help me with the syntax quickly? So you can say drop table. All right. Now, when we drop the table, in case of external table, the this folder will exist. You can see that the folder is not deleted, neither is the data. Now let's go back. I mean, this is very important. Why I'm trying to say, because probably that is the reason why when we I was starting today's session, that's the reason why the data got deleted. Okay, because if you create the same table as internal and then delete the table, then the underlying folder, this particular folder, will get deleted. Okay, so if we create a managed table here, if we create a managed table here, okay, again, uh, you can see that, okay, the same folder is existing still, okay, and same folder is going to be used. So we can say select star from my stocks. Okay, so it's able to quickly load the same table. But the moment we say drop my stocks, it is going to delete the data. All right, if we say drop my stocks, drop table. Now look at this. Let's go back here and try to refresh it. There is no folder with this name. Okay, so which essentially means that it has deleted the folder. So what did I do? I created a managed table, okay, and then dropped the table. So it actually deleted the data. Do I make sense to you? So is this clear? The difference between a Hive table and I mean Hive internal table as well as external table. It took me some time to understand when I started with Hive, and these were the exact problem which I faced as a confusion, and so that's the reason I'm explaining these things. All right, coming back to our the usual discussion. All right, so that essentially means that when we drop a table which is external, our data remains intact. So whenever you are trying to churn a data by third party which you do not have permission to delete, or you do not have permission to uh, you do not have permission to alter. In those cases, you create an external table. Okay. Shalina, you have some question? You have raised your hand. All right. All right. No questions. So I hope this is clear to all of you. And so external table cannot. Using external table, we can load the data from remote sources such as S3. Okay. So imagine this: you have got humongous data lying in S3 bucket. You don't require all the data all the time. You require only some data sometimes. Okay, and at that point of time you might want to just access a portion of the data. Okay, In those cases, you can use an external table and mention that our location is on S3. So you can create an external table like mini wiki stats, providing all the columns, and then mentioning that our row format is based on space and lines are terminated by new line, and the location is this S3 bucket. So it will Hive will figure out based on the protocol in the URL that what we are referring to here. Okay, and accordingly you can it will be then when you say select star from mini wiki stats where blah is blah, then it will try to query this location. Vijay's question is, so if you do not specify the external keyword, then it is internal. Is that right? Yes, that's right. Okay, if we do not specify internal external keyword, then it's a managed table, the usual tables. Okay. So as a thumb rule, as a suggestion to all of you, if you are trying to create an external table which is pointing to our data slash NYSE, do not if you are basically trying to load this data, be very cautious. Try to create external table instead of internal table, because there are two things. So let's say that we had some data lying in our folder. You created imagine that you created an managed table, all right? And after creating a managed table, what you did was you did a load. And the moment you do the load and the data is lying on HDFS, the data moves. Okay, the data moves. The uh, it's basically a way to optimize the space. Okay, we should not be creating multiple copies of the same data in HDFS. That's the reason. And when the data moves, so once the data has moved onto your managed table and you drop a managed table, so the data is gone. Okay. So although for you it might be that I created my table, I loaded this data, and I deleted my table, what harm can I cause? Okay. So but you can cause harm because while loading from HDFS, the file moves, not it doesn't get copied. All right. Okay, so enough of external, internal. Any questions here? Please feel free to ask. I know there'll be doubts, and I'll assure you that other people will have the same doubts. Okay, so feel free to ask if you have any questions. So no doubts. All right, all right. Now there is a question from Danan. While location is at remote, does HDFS makes a copy of external data? No, it doesn't. Okay. So whenever you are querying, so the question from then and is that if the location, the way we has said here that the location is S3, now will Hive copy this data locally? The answer is no, it won't. And due to this, your queries might look really, really slow. All right. Also, if you want to make a copy of the external data, instead of specifying the location, you could also have said load the file, right? In those cases, it could have copied the data to this location. The reason why you are specifying a remote location is because you want to you don't want to copy the data. Okay. And further to this discussion, then an external table can also have multiple partitions. All right. So one partition comes from S3, other partition is coming from some HDFS, and there could be other partition that could be coming from somewhere else. Now, when you query and you specify a where clause, so the data which is qualifying in that where clause might be in one partition or more. Okay, may not be in all the partitions. So only that particular partition or that only that particular remote location will be queried. Only that particular data transfer would happen at the time of querying. All right, that particular as in the data which is qualifying in the where clause. Yeah. So as you can see in this one, this is an external table called log messages. And these log messages are partitioned by three columns: year, month, and date. Or you can say that it's a composite key of three columns. Now, when we are creating an external table which is partitioned, so when you're creating an external table which is partitioned, you don't necessarily have to specify the location. You can keep on adding the location at a later point of time. You can see here, we are adding a partition. We are saying alter table log messages and add a partition, and this is the location of our data. Then we could also again add one more partition for this year, this month, this date. We could also add another partition for year 2011 and set the location this. Okay, or you can say that in another words, in year 2002, all our log data was kept on HDFS. Therefore, we are creating this kind of partition. And in year 2011, all our data was in S3 bucket. Okay, so basically, this table called log messages abstracted out all the complexities of the data. Okay, under the hood there are two different locations for two different years. Okay, and still it's able to handle that complexity under the hood without bothering the end user. Okay, after you have created these columns, what would happen is you can say select star from log messages. In that case, the data from both the locations will get copied to your machine, I mean to the Hive server and get displayed to you. Okay, and then data is not kept locally at all. Okay, again, if you are saying select star from log messages where year equals to 2012 and month equals to 1, or just year equals to 2012, in that case only the query will go to this particular location. Okay, so imagine this: for 1 year there will be 365 files, and if you are just querying for a day, then the data from only one file will get wi- will get transferred. Okay, so this way you can optimize a lot of transfer of the data. Similarly, you can also create a singular view for your developers, for your engineers s- over the data, so that they can simply query this table and without having to deal with HDFS or S3 under the hood. All right. So this is external partition. So I mean, again, if you drop this table, it would not impact HDFS or S3. Okay. As a thumb rule, keep in mind that whenever you, even when we do the project at the end of this session, whatever data you are using from external parties, the input data, always keep external table for that. The intermittent tables which are only useful during the process, all those tables should be kept as managed tables. Okay. All right, again, whatever we have discussed, each table has got a location, right? And by default, the table is a directory under this location. You can override that location by mentioning location in the create table clause. Load data copies the data if it's local. Load data moves the data if it's on HDFS. Dropping manage table deletes the data uh, at that location. And okay, and dropping external table does not delete the data. Okay. Also, the metadata is stored in relational database called Hive, and it is called Hive metastore. Okay. You can have a look at relational data if you basically do MySQL minus u, right? So we can say show tables, or you can say show databases, and we have Hive, use Hive, and we can say show tables again. So this is where Hive will be storing all the data. Okay. Any table which we created today would already be lying here in these. So you can see there is a table called TBLS. So the information we created today, the tables we created today would also have an entry in this. All right. So you can have a look at it and understand that Hive's metastore is stored on a single machine, not on all machine. Okay, because here we are not expecting too much of writes into the table. Therefore, it is okay to have a single machine for keeping a Hive metastore. All right, did it make sense to you? Should we move? All right, great. Now, the usual select statements are also called projections, and these are in select statement you can either specify columns like usual columns, and in case you have given a name to your table, like in the second syntax where we are saying, like we are saying here, select, here we have given E as the name to employees. We are saying select E dot name, E dot salary from employees. Okay. And okay, also, I mean, this kind of syntax is great if you have multiple tables in the select statement while joining the two tables or three tables, or in those cases, giving alias is good. Also, the computation on columns is it can be done just like our usual tables. So, in our usual tables, Oracle or MS SQL or MySQL, we can specify any formula and that gets evaluated. Similarly here, so we can say things like select upper, and then upper is a function which converts the lowercase to uppercase, and we could also use the complex data type as we had discussed earlier. So here deductions is a map, so you can access the values of the deduction, and Similarly, we can use a very complex formula such as round of salary into 1 minus deductions this. Okay, so this way you can specify a complex formula in the projections. Okay, all right, any questions here? No questions? All right, so feel free to ask any question at any point of time. So Vijay's question is, can you tell me more about the map, the deductions? Okay, going back to the initial discussion where we created this table. Yeah, so you can see that this is how we have defined the map here. So while defining your table, you will be defining deductions like this, where the data type is map, string, and float. All right, great. So Achintya's question is, can we use nested queries like select star from table where, yes, definitely you can use that. Okay. And as an exercise of today's session, you might have to do a nested queries. But personally, I always recommend set based operations rather than doing a nested queries. Okay. So nested queries can be converted into normal joins, okay, by using left or right outer joins. So prefer the left or right outer joins because most of the databases, they perform far better with joins instead of the nested queries. All right. All right. Now, okay. Similarly, we can also do aggregations. We can say select count star and average salary, some salary, and these operations easily. Okay. And sometimes it is beneficial to do a map side aggregations. Okay. So sometimes, say for example, you have to do count star. Okay. Count star, if you think about count star, if the way you have to do, you can do count star using map reduce would be that we can count on the side of the map itself. There is no need of a reduce. Okay. So those kind of minor optimizations are possible using hive.map. Okay, using these kind of top level aggregation. So if you set hive.map.aggregation equals to true, okay, then the then the aggregation will finish in the map page itself. All right. All right. Okay. So this is something very important here. Something called views. Okay. All right. So when you are building a complex query, rather than trying to fit everything into a single query, you need to plan. You need to plan such that you can uncomplicate your query. Okay, imagine that there is a big table. You only wanted three columns out of it, and then you want to do some operation on top of it and join with the other table. So instead of again and again selecting those three columns, you create a view of those three columns alone. Okay, so any view. Okay, so any view would be a query. So if you have a complex query, you can basically split it into subqueries and create views out of it. Okay, coming back to Achintya's point, a better idea would be to create a view on one of the subqueries, and then you join it with your main table, and that way by joining left or doing a left outer or right outer, or you could exclude a record from this, and those kind of operations you can do. All right, we must have done left outer right outer during pig session. Okay, so generally using views you can uncomplicate your queries so that you can so that your whole whole query becomes easier, the whole project becomes easier. Otherwise you will have to either use temporary tables or do something else. All right, I mean, the single big advantage of pig over hive was one of the advantages, not single big. One of the advantages was that pig queries are far more simple, one step at a time. Okay, the similar behavior can be emulated using views. So for example, this query we'll be using at the later point of time during the project. So we have the raw data in the form of tweets. It has got lots of data, this particular tweet simple. And all we want is these columns, these four columns. That when we are doing Twitter sentiment analysis, the this table contains hundreds of columns. Okay, I will so it would be somewhere. Let me just go to my. All right, so user student. So here I would be having the data, not this one. So if you can see this data, uh, just one more up. So this is the raw Twitter data. Okay, and this data is basically in JSON format. We'll be loading it as a table, and there are so many columns. Okay, it's so these are so many columns. So a first step would be to basically pick up only those columns which we require and create a view on it. And afterwards, we will only bother about this table instead of this table. I mean, tweets underscore clean, although it's a view, it will behave as if it's just a table with these four columns, right? So and, if you are aware of the usual SQL, you must have used views already. All right. Again, view is nothing but a representation of a query. So the way Hive would work is when you are joining a view with another table or joining view with another view, what it would do is it will, under the hood, it will prepare the complex query. Okay, view will expand into a query before the execution. Okay, so view does not hold any data. Okay, so we cannot say things like load data into tweets underscore clean. Okay, because view doesn't have a location. That is the difference between view and a normal table. All right, so now let's discuss something uh, with respect to UDF, similar to pig UDF. So a lot of times when you are dealing with data or dealing with Hive, you will be in a situation that you require a particular function, in Hive, and that function does not exist. Okay, imagine that you have some functionality in Java, and you want that particular functionality. Let's say all you want is find out, uh, convert to uppercase the third letter of each word. Okay, such kind of functionalities are quite difficult to do in Hive. Okay, because character wise, you might have to explode the word into characters, then try to uppercase. So it generally becomes quite difficult. So for lots of cases, you will be in a situation that you require a custom function, which is not there as part of the standard Hive library. So in those cases, you can do the custom functions. And the way you do is, you, similar to pig, you extend a particular class and then implement a function called evaluate. All right. So, and once you're done with that, you create a function. For each function, you have to create a class, and then you implement a function called evaluate. This is where your logic will go. And afterwards, you can create a jar, export it as a jar, and and then okay, and then inside, okay, here after you have prepared the jar, you will copy this jar to the server where you are going to run Hive. And once you have done that, you will do add jar your.jar. Okay, whatever jar you have created. Also note that this jar has to be in the local folder. Okay. If you have put it in HDFS, then you will have to say here HDFS colon slash slash and the full path of your jar. Okay. Let me show you this. All right. Now, okay, here's my Eclipse. Okay, so like with the usual Java program, we'll have a source folder. Under this, you can define a package. And here it's like most primitive form. And the thing you should note here is, although the class name is lower, but here inside it I'm doing the uppercase. Okay. And just to keep it that way. And in the evaluate, what am I doing is we are getting text and we are returning text. If it is null, we are returning null. Otherwise, converting, we are getting this string out of this text and then converting it to uppercase and then again converting that string back to text. Okay. So this code is clear to you. Here, the other important aspect is every UDF, as in every user defined function in Hive, has to extend a class called UDF. And then you can say export, right click, and then you say jar, select it, and then you give it a name. Let's say I'm calling it sg-hive and UDF. Okay. Now it has, so let me, alright, so if you go into downloads, you should be able to see sg-hive file. You can see. So it just created just now. Hadoop fs copy, not sorry, we have to say scp and then this location because this is on my laptop, and then we'll copy onto Hadoop 1 student Hadoop 1 dot nobigdata.com slash colon ascii. Alright, so we can say now here ascii. Now you can see that you can see sg-hive here. Alright. Now inside our Hive query, inside our Hive this prompt, we can say add jar ascii slash. Okay, so it has added our jar into class path. Okay, this is important. At this point of time, Hive will try to understand the functions your jar has declared, and when you run a query, it will execute those functions. All right. So let's say, for example, also you can create an alias. Okay. So it says that sg.lower is not found. Okay. Just a second. It is my lower. Yeah, here. All right. And all right. Now when you run it, let's try to run this function called, okay, you can see, although it's a small thing, but it is again going for the map reduce. Number of reduce tasks is 0 as there is no reduce operator, and it has given you a tracking URL like the way it gives you while running a map reduce job. Okay. So it has converted into lower uppercase. Right? And why? Because Our function internally is actually doing the uppercase. Any questions for me at this point? No questions? Okay. The Anand's question is, can we create it as a permanent function to be used by other users? Okay. So the other way of doing this is, how should I? Okay. Okay. So Hive does not provide you a right, I mean, out of the box functionality of creating a function which can be used by everybody. Okay. Right. So whosoever has to load your jar, he has to copy it in, download your jar and then start using it. Okay. If you are talking about a scenario where you are in an organization and what you want is, there are a lot of legacy functions which you want to be provided to all the people in your organization, that kind of functionality is not yet possible. All right. But it's not that difficult for everyone to basically do add jar, whatever jar you have provided. All they need to do is add jar and then start using the functions. All right. Makes sense, Dayanand? All right. Any other questions at this point of time? Okay. So sometimes you might have to load some other data, some format of the data which is not there in the classic Hive. Okay. Say, for example, you have to load JSON data. In those cases, you might have to write your own SERDE. SERDE means serializer, deserializer. You might have to create your own serializer, deserializer class. Okay. The way we had defined our UDF, in the similar manner, you can also define your serializer, deserializer. If you extend something called SERDE, then you'll be able to define your functions which convert a plain text into columns. All right. But generally, for most of the formats, you will find the SERDE, as in serializer, deserializer, available on the internet. So you can basically download the JSON SERDE binaries and start using them to load the JSON data. Okay. And what is JSON? JSON is a format like this one. You can see this format. So I'll just try to format this data well. So this is the tweets data provided by Twitter, and this looks like this one. All right. So this is a JSON format. It says that from here to here, it's a full object, and this particular variable in this object is a string. This is null, and under this there is another object called entities, and symbols is an array, and URLs are also an array of objects. So you can define a very complex objects using JSON. Okay. So say you have to load JSON data. In those cases, you can download JSON Serde binaries and then add those jars onto your into your Hive, and then start using in this manner. You can say my row format is defined by this particular Serde. Serde means serializer and deserializer. Okay. So what will Hive do in this case is it'll read the data from actual location, which is this, and then for each line it will be calling this particular class, and this class will convert the text from that file into records. Okay, so that is the role of a serializer and deserializer. Okay, similar to input split and other customization behavior, Surdays provide you the ability to load any format. Okay. All right. All right. Before moving on to sorting, I have a few questions to ask you. So first question is that question number one, in our word count, in our word count example, if we had two reducers, how many output files would be there? Since you guys are not asking questions, I am starting to ask questions. Great. So two files would be there. Thank you, Achintya. So, all right. Thank you, Dayanan. Vijay, there will be two files. Although there will be a single folder, but there will be two files. Great. Now two. Okay. Now second question is, if your input data is, say, apple, ball, bat, and and say, all right. Let's say this. Okay. So this is your input data. So which one is most probable? So first answer is reducer 1 would have apple and art, while reducer 2 would have bat and ball. Answer B is reducer, all right, reducer 2. Okay, so which one is more probable from your perspective? I'm just ordering things correctly because the output of reducer is generally is always sorted by keys. Okay, now which one is more probable in default settings? Have you have you tried tried our word count example. So a question is that if you have two reducers, it will be creating two files. Are those two files overlapping, or are they two files completely disjoint? Meaning, if you concatenate those two files head to tail, will they form a sorted result, or will it be unsorted? All right. So which one would be the result of our usual word count? So Manoj says A, Srilana says A. Anybody else? All right. The thing is, the answer is B. Answer is B. All right. So the way it happens is, for each word, for each word, there is something called a partitioner that decides whether this word should go to first reducer or second reducer. In the default settings, that partitioner works on the basis of a hash code, which is which is something which is basically, you can think of a hash code as if it's summing the ASCII values of letters and then dividing it by some random number, so that so that the the two reducers should get the equal number of words. Okay, so that the instead of the default partitioner tries to make sure that both the reducers are equally loaded, and that is why it does not do it alphabetically. So in default setting, the partitioner does not partition the data such that the two ranges are completely disjoint. Instead, it creates the range, it creates the output, it makes sure that both the reducers are equally loaded. Okay, so the answer is B, this one. All right, is it clear what I was trying to explain? Serena and Manoj, Achintya, did they make sense? So the answer is B. All right, now again, so my third question in the same sequence is, if we concatenate the files, what was the name of the files? Part 00, part R0000 something, and part. All right. This is how our, okay. The concatenate the output files, which will the result be sorted? Yeah, yes or no? In our usual setting, in our usual word count, if you have two parts, these two parts, will the result be sorted? And let me check if I have, do we have, it is not there, word count Like these are the two four ones, right? So this is my part 0. Okay, and you can see, let's just take first 10 record from part this one. Okay, this is part 00, and let's take uh, first 10 records from second part. Okay, oh sorry, this we have okay, this is already solved problem. It doesn't. I'll have to do a little hunting around, because I'll have to find the output with two reducers without any. Nah, we don't have the usual one. We don't have. I think this is the one. All right. So let's take a look at this one. This is what, if you do the usual word count with two partitioner, this is the kind of result you generally get. Okay. So you can see these are the first 10 records from first partitioner. And okay. So in this, the format, the output format is, this was the word and this was the count. First value is the word. Now you can see that 005 went to the first reducer while 00 went to the second, 0001. So you can see that the usual partitioner has tried to create a balance such that both sides should get equal number of values. Yes. All right. So these are, that's correct, Vijay. Each individual files are individually sorted, but if you concatenate these two files, they may not be sorted. You can see that if you concatenate them, this is not sorted. 005 and then 1 and then again 00. So 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 usually the result of your sorting, if you have multiple reducer, is not sorted. Okay. Okay. So keeping this in mind, let's continue with our discussion regarding sorting. All right. So in the usual settings, when you say in Hive, when you say select star from my table, order by a particular column, it guarantees you the global ordering. But the downside of this is that it does it using a single reducer. And as we all know, that if we have a single reducer, we don't have to concatenate files. Instead, we'll get the result correctly, right? Right? So sometimes when your data is really huge, you do not want a single reducer, and therefore you do not use order by. That's the way order by was designed initially. Now, if we say sort by X, then it will try to create n number of buckets, n buckets for that particular column, and then sort, then give you the results. But the only problem is the data will be sorted individually in the buckets, but overall, overall, uh, overall, the data will not be sorted. It's like saying I am having n reducers, and each of n reducers will anyway will get sorted, but I'm just concatenating them. I'm not resorting them. That's what is sort by X. Okay. Now this also does not solve our problem mostly, and that's why you generally use a command called distribute x. Distribute x, what it does is it basically, while using multiple reducers, it will divide the data such that it generates the non-overlapping ranges for each of the reducers. It's like saying that please create a partitioner on my data such that our ranges do not overlap. The way one of the partitioner example, if you have gone through our code, there was a partition example saying if the character is starting with k or more, send it to the second reducer. If the word is starting with a something lesser than k, then send it to the first reducer. So distribute by x make sure that all reducers would get equal ranges. Okay. Sorry, all reducers will get non-overlapping ranges. All right, and that's when if we that's when the cluster by comes into play. So neither sort by nor order by nor distribute by solves our problem. Instead, if you combine sort by and order by, meaning multiple reducers and a partitioner, would solve our problem, and that's where the cluster by x comes into play. Okay, so thumb rule is, the conclusion of the discussion is, if you want to utilize multiple reducers for ordering your data, use cluster by instead of order by. Okay, cluster by make sure that our data is split into the ranges which are non-overlapping, and then each of the sections will be sorted and then combined together. Okay, so it is equal to saying distribute by x and sort by x. Okay, so cluster by in very simple words is the more scalable version of order by. All right, and to define that how many reducers to use, you can say a syntax like this. You can say cluster by a particular column into 32 buckets, and so those many reducers will be created. All right, any questions still here? No questions? All right, let's take a quick break of 10 minutes, and we'll be back by 8:45. Yes, we can order by multiple columns, definitely. That was, sorry, let me repeat the question. The Anand's question is, can we order by multiple columns? Yes, we can order by multiple columns. All right. All right, so should we start now? All right, so should we start now? Can you hear me clearly? So I think only the Anand is back. All right, so can we start now? Other than, is everybody back? Dayanand is back. So Selena, Akshay, Achintya, Vijay, Manoj, Sarad, can we start? All right, great. So in this example, in this particular demo, what we are going to do is we are first going to download this data. It's nothing but the ratings of various movies from movie lens. Okay, I have and you can use wget to download any file. All right, here I have already downloaded the data in my folder. You can see. Okay, so there is this file which already has everything. We can do unzip that, and we have. So in this folder you can see that there are many files. Out of this, what we are going to focus on is u.data. Okay, what does u.data have? To understand what is the format and what are other files doing in this folder, you can look at you can look at the readme file. It will show you what each of this information means. Okay, u.data has the full data set. It has got 100,000 ratings by these many users on these many items, and data is not ordered correctly. That it basically has these four columns: user id, item id, ratings, and timestamp. Okay, so again, going back to user id. Okay, user id, and then there is a item id, which is movie id in our case, and then rating out of 5, and then the timestamp. All right, now this is the data, and what we want to do is we want to do a lot of things on top of this data. There could be many things that you would want to do. So let's first represent it as a table. Okay, let's first represent it as a table. So we start Hive, and for this session we have created 20 June. Okay, now we are creating this table, and under this table we have select star from u underscore data. Okay, so the table exists, but there is no data inside the table. All right, now let's load our file. Let's load our file into this. Okay, so we are saying home student asgiri ml dash. This is the folder in which we have extracted our data just now. Okay, so it's saying copying the data from file, and then once it has copied, okay, it has removed the hdfs file which had the data copied. Okay, now you can see that out of this we can now quickly query the data. Let's say u underscore data. All right, now you can. So, all right. So we have been able to import the data into table and then query it. Now we can do a lot of things on top of it. Okay. Say, for example, we want to find out what is the average rating. So we can say things like select. Okay, so just a second. For each movie, how many users? For movies having more than 30 ratings. All right. So what we can do is select star from u underscore data. All right. And let's say what we want to do is for each movie, describe formatted. Describe formatted u underscore data. Select okay. So we can say select uh, average rating, comma, movie ID from u underscore data, group by movie ID. Okay. So what we are saying is we are saying give me the average rating of each movie. So we can do a lot of churning on top of this data very easily. All right. Do you find anything wrong in this? Okay. Let me again. So do you find, I mean, not technically, but approach wise, do you think this method of doing the average is correct when it comes to products? You must be visiting Flipkart, Amazon to see the products and then see the ratings. Do you think this approach is okay with you? Yeah? Anyone? So although we have here for each movie we have computed the average rating. Okay, we have computed the average rating, and we can further do a join with the other table. Sorry, yeah. So yeah, here there is something called u dot item. In this there is a names of all the movies. Okay, we can also load this particular file as a table in MySQL in Hive, where the data is separated by pipe. Okay, and then we can join this against our u.data and get the results. All right, coming back to my question which I was asking you, are you comfortable with this kind of model? We are saying that just compute the ratings by averaging it. All right, now in this the main problem in this method of finding average is that even though there is a very popular movie, okay, that might be getting 4 out of 5, but if there is a single movie which has been rated by only one person, that might also get a similar rating. Okay, so right. Yes, scalability could be an issue. That is Vijay's question. But this is fairly scalable when it comes to using Hive. It is fairly scalable. Okay. So what I would want is I would want the average rating for only those movies which has got at least 30 ratings. Somebody, at least 30 people have rated. Only for them I want to display the average ratings. Below 30, I would just like to display a blank, or I just don't want to display those movies with whose ratings is less than who total number of people for the movies. For the movies, if there are more than 30 people who have rated that movie, only display that, otherwise don't display that particular movie. Okay, so that is one of the assignments of today's session. Okay, you have to do this assignment, and for each movie you have to find out how many users have voted. First one is comparatively easy, second one is little difficult, so try solving it. Okay, all right, does it make sense to you? Just a second, I will be uh, detaching the headphone for a second. All right. Okay, any questions on this assignment? Srina, Akshay, Achintya, Dayanand, Vijay, Manoj, Sharad, any questions on this assignment? Yes, you can have having clause like SQL. That's correct. That was Vijay's question. If we can have having clause. All right. So try solving these two problems, and that will be good enough. All right. So we are starting something very important now that will continue tomorrow. And so let's start something very important, which is NoSQL and HBase. Should we start? All right. This is very important, and this is probably help you in many other scenarios also, not only Hadoop. All right. Okay. Uh, Now, how do you? Is it clear the comic strip? So comic is that if you do not have any expertise in any SQL, you can confidently write that I'm an expert in NoSQL. All right. And there is another joke which I heard recently. The joke was, uh, I mean, there is a bar, and two guys entered into that bar. They did not notice the name of the bar, and there are no tables in that bar. Okay, so what would be the name of that bar? The name would be NoSQL, because there are no tables generally. All right, so if you have no clue about SQL, then you can confidently write the. Okay, so the most important part before going further, I would like to describe you the difference between horizontal scaling and vertical scaling. Horizontal scaling is also known as scaling out, while vertical scaling is also known as scaling up. All right. Now, so there is a very big and drastic difference between the two, horizontal scaling and vertical scaling. So let's imagine that there was one person having one horse and a small cart. Suddenly he has to carry lot of stuff, and so he has two choice: either buy an elephant instead of a horse, or buy multiple horses, okay, and attach them to the cart. So which one you would like to go for? Yeah. All right. Vijay says depends on the cost. Good. So now it also depends on your vision. If it's okay to have multiple small carts and get the work done, or if you are carrying something like an iron, a bigger, I mean, a lot of load which cannot be splitted into multiple carts, then you probably would want to go for either of these models. Now, in either of this, each one has its own problems, but mostly the scaling out seems to be the solution, because that is inevitable. Okay. Reason being that when you are vertical scaling up and your elephant did not work out, even say a elephant is hardly 2 horsepowers, okay, equal to 2 or 3 horsepowers hardly. Eh, Okay. And if that doesn't work out, then you don't have any other choice. Okay. But if you have figured out how to scale out, then no matter what load you want to carry, you can always scale out. Okay. So instead of waiting for some elephant to grow even bigger than what you have, you basically figure out how can you utilize existing horses to get your work done. Okay. That is scaling out. And earlier, when people were buying supercomputers, people are still buying supercomputers, and people were building quad core, this, that, there were always problems. Okay. So this scaling out is something important here. All right. So the definition should be very clear. So if you have one computer and you got really high load, so if you buy more computers and connect them into a LAN and make them all handle the load, then we call it scaling out. Okay. That is our NoSQL way. And in case you try to buy a supercomputer instead of this computer, then that is called scaling up or vertical scaling. And that is what we have been doing for quite some time. Scaling up is what we have been doing for quite some time. Every organization is still convinced that scaling up is the only solution. The thing is, with scaling up, you do not have to change the card. As in, as in, whatever. whatever database were you using for scaling up, the, uh, for new computer, whatever you were database you were using, the same database, same software can be used. But when you scale out, the whole strategy changes. Okay, and most of the time you don't have an option of scaling up. Okay, so that was a little bit about. Okay, so we will discuss this point in more detailed manner. Why exactly do we need NoSQL now? Or why do we need the new kind of database? Again, a quick meaning of NoSQL. NoSQLs are these new kind of databases, new kind of databases which are required. Databases which do the distributed computing. Okay, that's the most important thing about NoSQL database. If somebody comes and says that, oh, we have built a NoSQL database which runs on a single computer, that's uh, that's simply stupid. Okay, all the sole purpose of NoSQL was, first, to handle the big data, second, to provide high availability, meaning high storage and high traffic, and third one is scale out. Today today your 10 computers are solving problem. Tomorrow, if you have to increase to 15 computers, the data should automatically rebalance. As you keep on adding more and more computers to the network, the data from existing computers should automatically flow. If you and similarly, if you are removing computers from the network, one at a time, it should not be much of a problem. Okay, there should not be any requirement to shut down the database in order to add more machines or remove any machine. That is scale out. Okay, high availability means that the traffic should be divided amongst multiple computers. Similarly, big data means, when we say that our NoSQL, we need NoSQL to handle big data, meaning the storage of all these machines should be combined together to cater to the users. Okay, so these are the reasons why we require NoSQL. When you have humongous data, when you have lot of requests coming in, and when you have this requirement of handling the load dynamically, I mean handling the load, uh, and you know that today we are handling few terabytes, tomorrow we'll be handling few hundred terabytes, and so on. All right. So is it clear? Basically, why NoSQL? As if I have to answer in a single word, I would answer distributed computing. If we have to provide a storage which is distributed, I will use NoSQL databases. All right. These are the few characteristics of a NoSQL database. All right. So most important out of all these features is distributed architecture. Okay. Now you can imagine, before we go further, every NoSQL has got a notation for a table. Okay. Table, as in their definition of table is very different. Okay. It doesn't have columns. It not necessarily has to have columns. But all of these, everywhere there is a notation of a table. Okay, there is a notation of a table. For example, in Cassandra you have table, HBase you have table, MongoDB you have table, and so on. Okay, just that in MongoDB a table is called collection, and in case of HBase table is called table, and so in everywhere this data set called table or set, this set is broken down onto multiple computers and kept on multiple devices, and these multiple computers can cater to the end user. All right. So that's a general thumb rule. That is distributed architecture. The database table or or the data set is split into multiple computers. That is the distributed. In almost every NoSQL database, that is the common phenomena. And when you divide a data set into these subsections, each the record in the data set, a record in a data set has to be tagged with an ID, okay, so that we can quickly retrieve or figure out where on which computer in the network does an ID exist. Okay, so if you have you can when you think about it, if you have humongous data set and when you are dividing the some records, we are sending some records to one machine, some records to another, and so on. Okay, we would be making some kind of a record, we would be making a note of things like which data is going where, right? And that is why we require an ID, right? So each record in every database is marked with an identifier. All right, now you might ask that how did we do it in case of HDFS? HDFS is not NoSQL database, but still, since HDFS is distributed, did we have an ID there? Anyone? Yeah, anyone? So I'm saying here that in case of a NoSQL database, we have a huge table, and this table is spread across the network. And this table, or you can say data set, this data set is made up of records, and some records are one machine, some records are on another. And since records are distributed, to identify each record, we give them the name, and that's what is called as ID. So question to you is, in case of HDFS, we also had the same problem, right? Some files on one machine, some file on another. What was the ID? Anyone? No? All right. Correct. Thank you, Sarath. Sarath says it should be name node plus data node. Achintya is saying name node will contain IDs. Yes. So if you think about it, the ID, the name node will, yes, will maintain the ID, and this ID will be made up of the file name, okay, because file name is an identifier which identifies the file, right? And the whole data is basically collection of files. So you can think of ID as a combination of file ID, file name combined with the block ID. That is the ID that name node takes care of. Okay. All right. Yes, name node will make keep a note of which give the IDs to each block, and the ID of each block will be based on file name and the block ID. Now that question is that in all these databases, who gives this ID? So generally this ID is auto generated by the database, and and sometimes the database also gives you the ability to define the IDs. In case of HBase, you have to define your ID. In case of MongoDB, if you do not specify ID, it will create its own. If you specify ID, it will accept that one. All right. Okay. So a NoSQL database has distributed architecture. There's an Because it's a distributed architecture, there has to be an identifier for each record. And NoSQL represents many things. Okay. Literally, it meant not only SQL. and it's non-relational, meaning it's not able to provide you the all the properties of relational database. It's open source. Almost every NoSQL, there are around 150 NoSQL databases in the market, and all of them share these properties. Why open source? Almost all of the all of the NoSQLs are open source. The reason is a database is a very high engagement product. So if an organization is adopting a NoSQL database or any database, they have to have the surety that in case the company who is selling this database to me, in case that company shuts down, their data should not get locked in. Okay. Horizontally scalable, meaning scale out, as in you can keep on adding more and more machines and so on. Schema free. Most of these NoSQLs, because they are not able to, because they are designed for performance, they are designed for load. So most of the NoSQLs have decided to stay away from schema, because if the moment they try to enforce schema, it's very difficult to distribute the records onto multiple machines. And if they try to enforce the schema on a distributed architecture, it becomes extremely slow. It becomes very slow. And therefore, almost every NoSQL has stayed away from schema. What does it mean by schema? The way we were defining the table in Hive, and we were upfront defining that these are the columns and these are the data types of columns, and there's a referential integrity. I mean, not in Hive, but in traditional sense, the schema we need to define upfront. Okay, so none of the NoSQL databases, not even one has the schema constraints. Easy replication, simple API, manage huge data, and commodity hardwares. Okay, now you will understand these design principles of NoSQL once you understand the actual problem. All right, we will we'll just go over this one quickly. So there are four general categorization of NoSQL stores. First one is column oriented. Column oriented as in we also call them wide column. They look like our usual tables, but they are column oriented. We will talk about column orientedness in a minute. All right. They basically look like they are the closest to our database database. Their tables are similar to these tables. Okay. So a column oriented or wide column databases look very similar to our existing MySQL or Oracle tables. Then there is a second kind of database called document oriented database. In document oriented database, or sometimes they are also called object databases, large object like JSON can be stored into the database. Each record, in our case, in case of MySQL, the in case of MySQL, each record is an array of values. Okay. Okay. Each record is an array of values, and in MySQL. But in case of MongoDB, each record is a complex JSON object. The way we had something of this sort. Let me show you the one which we were doing, like this one, right? If you have to store such a complex structure, you can store it in the document oriented database. Something like this: we have TV shows, inside TV shows we have seasons, inside seasons we have episodes, episode has reviews, and episode has cast members, and so on. All right. Now, this document, this complex object, if you try to store it in MySQL, what will you do? You will create one separate table only for TV shows, then one table for seasons, then there will be a third table which will contain the mapping between TV shows and seasons, and there will be a fourth table called episode, and there will be a fifth table which will represent seasons and episodes. Okay. And there'll be a sixth table for reviews, seventh table for episodes and reviews relation, and eighth table for cast members, and ninth table for the relation between episode and cast members. Okay, so you'll have nine tables to represent this structure. Okay, now when you have nine tables in the production time, every time somebody wants to uh, display the TV shows to end user, they will have to join nine tables, right? So to simplify that aspect, document oriented databases solve a lot of problems. Now, third kind of NoSQL database is key value. They are the most primitive, and they were the first generation of NoSQL databases. It all started with Dynamo, a database done by Amazon, and uh, basically the Dynamo was probably the first key value database, first database of, I mean, first NoSQL database. All right. So in key value database, you have key and the value. The value can be, earlier it was only the plain text that was supported. Now the key as well as the value both can be binary in some of the databases. Okay. Out of this, there is memcache db, and these are not really true database in a sense. These are more like database stores. That's why we are saying NoSQL stores. Okay, you have key and value, that's all. And your table contains only two columns, you can think of it that way. Now, fourth kind of databases are really important, and these fourth kind of databases are basically for storing a big graph. Okay, a graph as in a graph of a social network, saying this person is having these friends are having these friends, and so on. A graph could be to represent a map, like geographical map, uh, which where we have the relationships like which which place connects to which place and what are the roads and so on. All right. So these are the four kinds of databases. All right. This is a straight comparison of NoSQL versus SQL. Okay. All right. Question with the question from Danand is, under which category does big table come? The big table comes under wide column or column oriented one. Okay. Because HBase is just based on big table. Okay. Okay. So now in case of SQL database, so these are the straight comparison where you have, just a second. All right. So this is a straight comparison between SQL and NoSQL. In SQL, all of the databases were of the same type. There was same behavior. Every database has tables, and there was SQL to churn that, and there were same principle or same way the user was interacting with them. While in case of NoSQL, there are many different types. There is no standard per se. The only thing that is common in NoSQL is all of them are designed for high load and distributedness. Development history for SQL database is 1970s, while NoSQL is 2000. Examples of SQL database is MySQL, and in case of NoSQL, there are MongoDB, Cassandra, HBase, and so on. And data storage model in case of SQL databases always was relational, and in case of NoSQL, there has been no standard. Okay, everybody has their own different kind of database data storage model. Structure and data types are fixed in advance in case of SQL, while there is no such thing in NoSQL. It's generally dynamic, and in case of SQL databases, if we hit the upper limit, we generally buy a better hardware. But in case of NoSQL, that's not a problem. And the development model for SQL databases was mixed, as in most of the SQL databases were actually proprietary, except for Postgres and MySQL. While in case of NoSQL, every database is open source. Now, this is something important. SQL database, no matter what, always had this acid properties. And can somebody quickly tell me what is acid properties? Anyone? A for atomicity, C for consistency, I for integrity, D for durability. Great. Thank you very much, all of you. Thank you, Sarah, Dachentya, and Dayanand. All right, great. Now, data manipulation in case of SQL database is using a variant of SQL, while in case of NoSQL, there is no standard. Okay, so in other words, you had some standards in case of SQL relational database, but here, in case of NoSQL, most of the every database has its own design and its own principles. All right, all right. So that was a usual comparison. What is important is CAP theorem. We need to understand this aspect. So we just talked about that our NoSQL databases are not able to provide many features. And one of them was mostly these NoSQL databases are not able to provide consistency and transactions. Now, why is it so? So there was one person called Eric Brewisters, who wrote this paper saying none of the databases can provide all three features, and these are consistency, availability, and partition tolerance. So, no database in the world can provide consistency, availability, and partition tolerance. That's what CAP theorem or Brewster's theorem says. Now let me define each of them. So out of CAP, that is cap, out of C for consistency, A for availability, B for partition tolerant, only At most, you can provide two. You cannot provide three. None of the database can provide all these three features. Now, what does it mean? What does it mean? Consistency means all the nodes at the same time see the same data. Meaning, if if there are two users, user 1 and user 2, user 1 is writing the data to the database while user 2 is reading the data from database. Okay, so user 1, whatever data, if user 1 has come just 1 millisecond before the user 2, user 2 should see the data which has been written by user 1, because because user 2 is coming after user 1. Okay, also, whether user 2 is reading the data from one machine or another machine, user 2 should see the same data. This is consistency. This is called consistency. Because imagine this, if user 1 came in, wrote some data, went back, again came to read the data and observes that he's still getting the older data before his write, which means he will go panicking that my write is not successful. Whatever I has written is lost. So this is inconsistency. All right. Now, second one is availability. Availability, as in the database should be able to cater to as many requests as possible, and no request should go unanswered. Okay, even if the system has to give it an error, we should I mean it should give an error i- instead of not being able to respond to a request. This is availability, a guarantee that every request receives a response whether it was successful or failed. Okay, unlike consistency, availability is in case of consistency, it's very something like black and white, either database is consistent or not. Okay, but in case of availability, it's a grading, as in I'm this much available and somebody is 100 available, other person is 99 available, and so on. Okay, now in case of third one, which is partition tolerance, partition tolerance means even if there is a partition in the network, meaning even if some of the machines shut down, still the system should be able to work. System should be able to work even if some of the machines are shut down. Okay, the minimum partition tolerance level should be one machine, that out of a network of 10 computers, even if we can shut down one machine at a time, one machine we should it should work. That is partition tolerance. So out of consistency, meaning all the nodes see the same data, out of consistency, availability, and partition tolerance, you should see uh, always we cannot provide more than two features. None of the databases that are existing today can provide all three features. Anybody can tell me why is it so? All right. Now, in this diagram, you can see that none of the database lies in the center, meaning none of the database actually provide this. So, all right. So you can see in this diagram which database lies where, but more important than that is this. All right. So again, this is how I would like to explain what does it mean by cap theorem. Let's have a look at it. What are the various designs possible? And when we think about these designs, we'll be able to think about the databases with what we have seen so far. All right. In case of a single machine, like you have a nice single machine which is used by all the users. Okay. For reading or writing, everybody uses the same machine. In this case, the database will be consistent, meaning whatever one user writes, the same data will be seen by all the users. So same data will be seen by all users because there is a single machine. Okay. Now imagine that there are two machines, A and B. All the users who have to write the data or save some data, they go to A, while the users who want to read the data, they go to B. And this data flows from A to B. Okay. So now that is the second model. In this second model, we are able to provide availability. In case of first model, you can see that in case this machine shuts down, then there is no backup, which means there is no partition tolerance. Similarly, if one user comes and locks the database or is taking too much time to read the data or write the data, the others will be waiting in the queue, and therefore there is not too much of availability. Database is not greatly available. Now in the third scenario, so the first scenario is clear to everyone. All right. In the third scenario, we have got machine A and B. All users are still interacting with A, while A is saving the backup of the data onto B. So So in this third scenario, does it ring a bell? Do you recollect? Have you seen such system so far anywhere? Yes, it is like a backup. Y- Yes, that's correct, Danan. We have seen it in HDFS, right? You have name nodes backup, right? That time. So you have A machine and you are basically copying the data onto B machines. Now, in case B machine shuts down or there's a problem with B machine, users are not impacted. In case machine A is hit, this particular machine gets hit, users will quickly switch to machine B, and therefore users won't be able to would not have any impact. And therefore, the third model is available as well as consistent. Third model is not available. Third model is partition tolerant. So third model is partition tolerant but not available. Why not available? Because all the users are writing to the same machine, which means all users will be standing in the queue while writing the data. Okay, if you have huge number of users, there is no scope for um, expanding user base. All right. Now, can you all right. So these three diagrams actually represent most of the designs, and most of the designs are basically a combination of these three basic designs. Okay. So for example, HDFS falls into the third criteria, while the middle one is the design of MongoDB, and first one is your relational database. Okay, is that clear to everyone? All right. So this is something, some diagram I made. Okay, and this is the probably best way to explain cap theorem. Okay, because I found that a lot of users are always confused about cap theorem. So then, this was the best way I could do. Okay. If you have any doubts, feel free to ask right now. Selena, is it clear to you, Selena? And Dayanand, Achintya, Vijay, Manoj, Sarath? All right. If you have any question, feel free to ask because this is a very important topic. Because every time I meet people, they are not able to justify the use of NoSQL databases. And this diagram probably explains a lot about the reasons why we move away from usual database. Okay. All right. This is another story. So this story is something which actually happens and actually happened quite a lot in 2000s, as in 2004, 2005, 2006, and so on. Okay, up to 2009 actually. So this story is not new. It's about every startup which failed pathetically in that duration. And I know at least couple of people who could not scale up. And so the story starts on the initial public launch. So you moved your data from local workstation and as well as your application from local workstation to the server, and you're happy to call yourself a great application. Okay. You moved your data from local hosted system onto a remote MySQL instance and you are pretty happy. And yeah, now after the initial public launch, after your champagnes, service starts becoming popular. There's just some PR release, and there are you start putting the advertisements, and it starts becoming popular. And too many reads start hitting the database. Okay, so when you have this kind of circumstances, a clever DBA or clever web developer will quickly put a cache solution such as memcached. So a cache solution such as memcached to it will actually solve your common queries. Okay, and after you have implemented a memcache, wi- I mean you will realize that every time you put a cache, what happens exactly is you suddenly become non-acid, as in it's no longer transactional. And reason is that the data which cache will be serving will always be slightly older. Okay, will always be slightly older because it takes time to reflect the data or reflect the changes in cache. Okay, so the moment you put the memcached, again your acid properties are gone for a toss. But still, the story doesn't end here. The service is still becoming popular, and suddenly you realize that there are too many writes happening on the database. You improved the reads by implementing memcached, but writes are happening really high. So what you do in these circumstances is you do the vertical scaling. It's a story of people who did it earlier. Okay, I'm not recommending that this is how you should do. Okay, so services starts becoming more popular, and there are suddenly you will realize that reads are okay, but too many writes are hitting the database. So what you do is you do a vertical scale up. You buy huge number of cores, huge RAM, and you put really fast hard drives and so on. Okay, so whatever funding you raise from a VC, you burn that money into this database hardware. All right. Still, now you realize that, okay, so you have solved all your hardware problems, all your software problems. Now you hire these product managers who are adding more and more features. or you hire more engineers, so you start adding more and more complexity to the whole application. And suddenly, let's say that you had this product which for which you started providing a rating as well as availability as well as, so your number of tables will start increasing, and so the relational properties of one table to another will also start becoming more prominent. Now, to serve a single product when you have too many tables, each table representing each feature, what would happen is you will be joining hundreds of tables just to display one product to your end user, and that might go very very slow. Now, when you have too many joins, what you do is you try to solve it, you do the denormalization. And the moment denormalization words come into picture, if you are from DBA background, you will almost get an heart attack saying, this is not what I was taught in the school. Denormalization is strictly no. Okay. Now, but the story doesn't end here. The database, your service is still rising in popularity, and it starts to swamp your server again. Things are getting too slow. So what you start doing is you stop all the server-side computation, such as no stored procedures and no triggers, nothing. So let's not do any computation on the server side. Now, even after this, there'll be some queries which are still slow. So what you start doing is looking at the queries which are too slow, you start pre-materializing all possible combinations of the queries. Now, if you look at this, you stopped joining, you stopped pre-materializing, you stopped direct away querying, meaning you are pre-materializing means you have already prepared the full query result and kept it in the memory that if somebody asks for the same query, I'll respond with this result. And if you look at this, and after this, still reads will be okay, but writes will still get slower. You will stop doing the indexing because as you keep on adding more and more indexing, so every record addition leads to entry in multiple indexes. Okay. Now, if you look at this closely, we ended up in a scenario where we are not we are basically not using a single feature from relational databases. We are not using triggers, we are not using stored procedures, we are not using foreign keys constraints. So slowly, because of high traffic requirement, we stop using all traditional features provided by our relational database. So relational database is fairly useless to you. Okay. You are not using indexes, you are not using primary foreign key, you are not uh, using any server side computation, and on the top of it, you are not using consistency, as in you have created your own cache. So effectively your this relational database is fairly useless to you. Any data store would actually help you if you are into high throughput requirements. All right, is that clear to you? How does rdbms fail when it comes to the load? Yeah. Any questions till now? We discussed cap theorem, we discussed about case study, we discussed about MongoDB, we also discussed about various kinds of NoSQL databases. So it's clear to only Sharad and Dayanand. All right, great. Thank you, Achintya, Sharad, and Dayanand. And let's I'm moving on. If you have any questions, please feel free to ask. Do not wait for me to finish. All right. So please do not wait for me to finish. Just if you have any question, please feel free to ask. All right. Now the next, so we discussed about horizontal scaling, vertical scaling, and all the basic things we require. Now let's also try to understand what does it mean by column-oriented database. Okay. When something is stored, displayed like a table, when something is displayed to the user like table, you can store that data in multiple ways. You can store them in column wise fashion or row wise fashion. Column wise means you pick up one column and store all its values first. Then you pick up the second column, you store the second column's value, and so on. Okay? Because the way the data is displayed in the table is always, we always think it like row wise, but it could equally be saved in a column wise fashion. Alright? So as you can see in this one, in case of row-oriented database, we will store first row, which means 10 and Joe, and after that we will store 12 and Mary. Then after that we will store 11 and Kathy. That is row-oriented database. So the display in case of row-oriented and column-oriented is same, a tabular display, but underneath the way it's stored physically is what matters. So the way it is stored physically, I mean, decides whether it's row-oriented database or column-oriented database. Okay. In case of column-oriented database, first column will be stored first, then second column, then third column, which means 10, 12, 11, and after that Joe, Mary, Kathy, which means that in case of column-oriented database, values of each column will stay together. In case of row-oriented database, values of a row stay together. Okay. Does it make sense to you? Any questions on this? No questions. All right. Now, in case of HBase is not really column-oriented database. HBase has taken a little political stand. I mean, it's in the same way as big table. It's neither the row oriented nor column oriented. It is something called column family oriented. Okay. And what is a column family? A column family is a collection of columns. Okay. So say for example here we have two column families, CF1 and CF2, and CF2 contains only one column called age, and CF1 contains two columns, employee ID, EMP ID, and name, and CF2 only contains age. So when we say column family oriented database, it means that all the values of a column will be stored first, and then the all the values for a column family will get stored first, then the values of another column family will get stored. So this essentially means that first this column family means these two columns will be stored, and then this third one. Okay. So and inside a column family, the way the data gets stored is in a row wise fashion, which means that 10 Joe, 12 Mary, 11 Kathy, and after that 23, 33, 45. This is how the data is getting stored. Notice the word stored. Presentation wise, it would look like a normal database. There will be no difference to the end user, but the way the data is stored under the hood. All right, is that clear? All right, so let me ask you a little twisted question. In a column family oriented database, if if there is one column family for each column, then then it behaves like a column oriented database, b column column oriented or row oriented. Yes, anyone? In a column family oriented database, if there is one column family for each column, then it behaves like perfect. It behaves like A. Okay. Now you can think of this way. If there was column family for this, column family for this, we'll store first that column family, meaning we'll store first that column and then second column and then third column. So, okay. So answer is A. Now in the same manner, in a column family oriented database, there is, okay, then it behaves like which one? Can somebody tell me? Correct. The answer is B. Thank you, Dayanand, and thank you, Sarad, and thank you, Vijay. Great, great. So this is clear to everyone, right? Now, some of us would ask this, and this is quite frequently asked, even in the interviews. Question is, okay. Question is, why do we have column oriented database? What is the benefit? Anyone? Anyone? The Anand says joins are faster. Most of the time, Vijay's answer is most of the time queries only select one or two columns, so the data locality plays a role in making it faster. Very good answer, Vijay. Thank you. All right. So other than that, there is another good answer. Reason is that values in a column are similar and hence compression is better. So few researchers realized that if we try to compress the data column wise, okay, then the results are drastically better than compressing the records row wise. We pick up one column's values and then compress. Okay. Reason is, and why the compression results better, the compression works on figuring out similarities. If the records which you are trying to compress, if they are similar in nature, similar, if imagine that in a whole column, if you have MF male female representation, then if you compress the data, the resultant data will be really small. Correct? In the same way, if you generally the column values are similar in nature, and therefore the compression results are far better. Make sense to you? All right. So HBase is consistent and partition tolerance database, is not highly available, and is column oriented database. It's column family oriented database, and is based on Google's big table, and is good for hundreds of millions or billions of rows and by millions of columns. Strongly consistent read and writes. So most of the databases realize that if they need to provide availability, they cannot provide consistency. Therefore, what they started doing is they started providing eventual consistent. In the long run, that everything is going to be okay. That is eventual consistency, meaning data from A to B. In the second diagram of our CAP theorem, the data from A to B is eventually going to reach B, and hence in the long run everything is going to be okay. That is eventual consistency. So HBase is not eventually consistent, HBase is strongly consistent. Automatic sharding, or the data is automatically divided onto multiple computers, and those nodes are called region servers. And in case one region server or one machine goes down, there is automatic failover. And there's a strong integration with Hadoop and HDFS, because HBase stores its data onto HDFS. Okay. Now, for computation in HBase, you can use MapReduce and basically uh, do a lot of churning in HBase. HBase does not provide you an SQL; it provides you a very simple put and get kind of queries, coupled with the MapReduce. It provides you the API in various formats. It has concepts like coprocessors and Bloom filters, which we will discuss tomorrow. All right. So that was about HBase. We will continue our discussion tomorrow. All right. All right. So any questions from me before we finish for today? All right. All right. If you have any questions, feel free to write us at Hadoop at No Big Data. And at the end of this session, there'll be a, uh, feedback. Please fill that feedback. That'll be really useful to us. All right. Okay. So thank you, everyone. It was a great set of questions, and I mean, keep asking questions as much as possible. All right. Thank you, Danand. Thank you, Sarad. Thank you, Vijay. Thank you, Achintya. All right. Thank you, Manoj. All right. Great. Bye bye. Have a great day.